Okay, so in this video, I'm going to answer the third question, which is the setting up the optimization problem for the monopolist. And how does it, and solving it, obviously, and how does it differ from the perfectly competitive market optimization problem? So, to begin with, let's sort of mathematically remember the assumptions, the key assumptions we need to move forward. Well, first of all, the firm, monopoly or the perfectly competitive firm, is facing a demand curve, all right? So by the way, in my lecture notes also, I use Y, so let me use P of Y. All right, so that's an inverse demand curve. So just to give an example, sometimes we say P of Y equals, I don't know, A minus BY, all right? So Y is the output, all right, the quantity, and then A and B are some positive constant numbers. So therefore the price is inversely related to the quantity, all right? So therefore this is a linear demand curve with a downward slope. All right, well, again, it doesn't have to be linear, all right? But we usually use the inverse demand curve. Well, you may say, well, what about the demand curve? Remember the thing that we say Q demand equals yada yada. Well, you can always get the demand curve from the inverse demand curve. How so? You basically pull Y alone and pull Y to one side and leave it alone, all right? So BY equals A minus send P to the other side, all right? And so divide both sides by B. So A over B minus P over B. So remember, Y is the Q. So here's the demand curve, all right? So we can always get the demand curve from the inverse demand, or vice versa. You can get the inverse demand curve from the demand curve. But we usually use the inverse demand curve simply because we don't have to make that conversion, because the price is we're just going to take the inverse demand curve and put it into profit function. It's going to be easier to operate. So whether it's a perfectly competitive firm or monopolist, there is a inverse demand curve, we assume, and then a cost function, right? So so Y is the output. So let's put that. So C of Y is the cost of output. So that's basically the only thing you need. So two parameters, all right? So the demand curve, inverse demand curve, and the cost function. In any numerical question, these two are going to suffice to solve the problem. All right. Well, what is the optimization problem? I mean, the firms are willing to maximize their profit. So that's an optimization problem, maximizing the profit. So what is the profit, first of all? Well, profit is always, whether it's a competitive firm or monopoly, doesn't matter. The profit is always revenue minus cost. All right, so it's very simple accounting. Well, what is cost? Simple, right? It's already given by the cost function. Well, what about revenue? Revenue is the amount of money you raise by selling your product. So let's say one product, so this is the product you're selling, say one product is $1, all right? So if I sell 10 of those, how much money am I gonna get? 10 times $1, $10. So that's my revenue. So revenue is always price of the product times the quantity you sell, all right? So therefore, the profit of the monopolist, and by the way, mathematically, we always denote profit by pi. So pi is always equal to revenue, which is P of Y. Remember, you're free to choose the price as a monopolist, and the price is a function of quantity. If you choose different quantity, you're gonna get different price, right? So the price times quantity minus cost of quantity, all right? Well, what about the perfectly competitive firm? Again, the profit is equal to revenue. Okay, so is it again PY times Y? Not really, because remember the assumption, as a competitive firm, you take the price as given, right? So P, which is the perfectly competitive market price, perfectly competitive market price, Comp means competitive. And we know, I mean, remember how we determine the perfectly competitive market price. Demand equals supply. So it's outside of the control of the firm. So the price times quantity minus costs. All right, so that's how we set the competitive firm's profit. So let me put pi c to denote that this is the profit of the competitive firm, and pi m is the monopolist profit. Okay? So if you remember in the previous video, I said the monopolist can choose not only price but also quantity. But here, it actually only choosing quantity, right? Because choosing quantity will determine the price and will determine the cost. So therefore, the monopolist is actually choosing, quantity only. Well, that's true. In fact, how you could have written the monopolist profit is as follows. P times Y minus C of Y, subject to P equals P of Y. All right? So that means as a monopolist, you can choose P, your price, and quantity Y. But the thing is, if you choose the price way different than what your demand curve recommends you to choose, well, you could not be able to sell all the products. All right? So for that reason, your profit is this, subject to if your price actually coincides with the market clearing price, all right, which is P of Y, given that you're producing Y output. So if I'm going to maximize this, this is a constraint maximization. You can write the Lagrangian, etc. I mean, it's a long way. You can just substitute. Use the substitution method. It's easier. So you can just, whenever you see P, just plug the P of Y, the inverse demand curve, and then you get one function with one variable. So this is exactly what we got. All right. So you don't really have to worry about this constraint profit function. Okay. Well, remember the objective of the firms, whether monopolist or competitive, is to maximize profit. And because this profit function is a function of output, so you choose Y, which is some real number, positive, non-negative real number. You choose Y, your output, to maximize your profit. Well, same here. As a competitive firm, you try to maximize your output, which is again a non-negative real number. So this is R plus, so it means it's non-negative real. And so you try to maximize your profit. There's no subject to, so there's no constraint. Good. Well, how do I maximize a function, a profit function? Well, simple. The first order condition. The first order condition. You take the derivative with respect to the variable that you're trying to maximize, which is Y, set it equal to 0, and solve for Y. Exactly here. The first order condition. All right, you take the derivative with respect to Y, set it equal to 0, and solve for Y. Right? That's what you should do. Well, you may ask why. You probably have learned this in calculus, but it's a very quick recap. The profit function, assuming that it has a nice shape, something like this. So this is quantity, this is profit. Okay? You are actually trying to figure out what this point is, Y star, let's call it. Well, again, whether you're a competitive firm or not, let's suppose this is your profit function. Well, what do I know about this point? Well, I know that obviously drawing the graph of a profit function is not always easy and feasible. So finding a generic solution is always a better idea and approach. So what we know is that here, if we draw a tangency line at that point, it's horizontal. meaning its slope is 0. If you draw any other tangent point, tangency, all right? So it's tangent at that point, it's tangent at that point, although it doesn't look so, I'm sorry. You see the slope here and here, they're not 0. Here it's positive, here it's negative, all right? So this slope equals 0 means something. We call it critical point, all right? So you take the derivative of the profit function with respect to the variable, set it equal to 0, and solve for it. So for some y star, so y equal y star, it's going to be equal to 0. So that's the critical point. We call it first order condition. Usually you have to, so that's first order condition. Usually you should also verify the second order condition, all right? Meaning you have to take the derivative, the second derivative. I mean, you take the derivative, don't solve it yet, you take the derivative again with respect to y. That's what that notation is. And if this is negative, it means actually your slope, not your slope, the slope of this function is going to increase, is going to be positive, it's going to be 0 at some point, and after that point it's going to become negative. So meaning it's a concave function. So this critical point is actually the maximal. So if your profit function is something like this, the slope here will also be 0. So that's a critical, so it satisfies the first order condition, but if you calculate the second order condition, second derivative, it's going to be positive. So it means it's minimal, all right? And sometimes if you have a function something like this, I don't know, again, at this point, the slope is going to be 0, but it's neither maximal nor minimal, all right? So the second order condition matters, but in my class, at least in this course, you don't really have to worry about the second order conditions, all right, unless otherwise stated, mostly because I'm going to assume either linear nice or convex cost function and linear demand curve so that the profit function is going to become concave, so you don't have to worry about the verification of the second order condition. But in general, you should definitely make sure that the profit function is concave. If it is not, well then the point that you're finding is actually not the optimal point. All right, so be careful about that. All right, so how do we solve this first order condition? Don't forget, this is a generic solution. Later I'm going to give a numerical example. But we need this generic solution just to for the next video because I'm going to compare and contrast what we should be learning from the monopolist optimization problem in relation to the perfectly competitive firm's optimization problem. So if you take the derivative of the profit function with respect to y, well, it's simple. You're basically, so, oh, by the way, one thing I forgot to mention, I usually use del. In general, in mathematics, we use del if the function has 2 or more variables, and we use d if we have only one variable. But I'm not going to really make that distinction. I kind of get used to del, so for that reason, I'm going to, stick with del. So for those math geeks, don't be confused with that. So the del pi m del y, the derivative of the profit function, it's in fact derivative of the revenue with respect to y minus derivative of cost with respect to y, right? So if you remember our arguments in intermediate microeconomics 1, the derivative of revenue with respect to y, we always call it marginal revenue, and the derivative of cost with respect to output, we call it marginal cost. All right, so that's equal to 0. That means marginal revenue equals marginal cost for monopoly. Okay, so the marginal cost, remember the cost is same whether it's a perfectly competitive firm or monopoly. So marginal cost is the same, so we don't need to put M or C. But the monopolist, the revenues are different objects, functions, right? So therefore, their derivatives will also be different. So just pointing out that. However, same here. The del pi, the competitive del y equals, again, marginal revenue minus marginal cost equals 0. Hence, marginal revenue equals marginal cost. Let's call it MRC. So whether you are a perfectly competitive firm or monopolist, doesn't matter. Your marginal revenue must always be equal to your marginal cost. All right? So what do we learn from this? Next video. All right. Continue. What is let's open up what this marginal revenue means in this example. In the monopoly case. In the monopoly case, the marginal revenue is equal to derivative of this function. So this function is like f times g d dx. All right? So I'm taking the derivative of a multiplication of two functions. So it's derivative of first function times second plus derivative of the second function times first, right? So I'm using exactly this. So it's derivative of the demand function with respect to quantity times quantity plus derivative of y with respect to y is just 1, so it's just p. So this is marginal revenue for monopoly. For marginal cost, it's derivative of the cost function. What about the marginal revenue of the competitive firm? The revenue is P times Y, and P is a constant number. Remember, because the competitive firm is a price taker. So it takes P as a given. It's 2, 3, I don't know. So the marginal revenue of the perfectly competitive firm is therefore derivative of 2 times Y. Think of it that way. So it's just 2, or just P. Okay? So the marginal revenue of the competitive firm is P. However, the marginal revenue of the monopolist is, P plus, Y times some term. So what do we learn from this? If you look at it, this term is always negative. Why? Well, because this is a normal good. I forgot to mention in my previous video, we assume that the good is normal, meaning, no, I didn't forget. We talked about downward sloping demand curve, right? So we already mentioned, I just didn't say it's a normal good. So as the price increases, quantity will decrease, or as the quantity increases, price will decrease. So there's negative relationship between price and quantity. So therefore, when you take the derivative of the downward sloping demand curve, it's going to be negative. So therefore, the marginal revenue of the monopolist is less than P, right? Because this is P plus some minus term. So this is less than P. So therefore, conclusion, at least for this video, 1, the marginal revenue of the monopoly is equal to marginal is equal to marginal cost, and then marginal revenue of the competitive is also equals to marginal cost. But don't forget, this doesn't mean, all right, so that's a huge mistake. Oh, then marginal revenue of the monopolist should be equal to marginal revenue of a competitive firm. No, there's no such thing, all right? Because the marginal cost is sometimes true, but sometimes not, all right? And in fact, we just have shown the marginal revenue of the monopolist is less than the marginal revenue of the competitive firm because it's equal to P, and this is equal to P plus del P del Y times Y, which is negative. So this term is less than P. All right? Well, why? You may conclude MRM equals MRC because they both equal to MC. It's like MC is not necessarily a constant number, all right? So MC is a function of Y also. For example, if your cost function is Y squared, all right? So the marginal cost is 2 times Y, all right? So this is 2 times Y, and your marginal revenue is equal to 2 times Y. The marginal revenue of the competitive firm is also 2 times y, yes. But the thing is, here, we have additional constraint that is also equal to P, all right? So MRC is also equal to P, and hence marginal cost is equal to P. So therefore, the Y that satisfies this condition is going to be different than the Y satisfying this condition. And hence, the marginal cost of the monopoly is going to be, at the end, is going to be different than the value of the value of the marginal cost of the monopoly will be different than the value of the marginal cost of the competitive firm, because again the competitive firm's marginal cost and marginal revenue should satisfy additional constraint, additional equation, which is they're both equal to P. So actually, yeah, I think I should also talk about, I should start from this discussion in the next video and discuss what we learn from all this, all right? So it's coming up.